So in this unit, we're going to talk about basic statistics. And having a basic understanding of statistics is actually something valuable, okay? Because a lot of times, you know, you may have seen something in an ad or heard somebody say something like, you know, 92% of people surveyed say this or prefer this, or 9 out of 10 doctors recommend this headache medication, things like that. You want to be able to understand, what does that mean when people say that? Okay, and is that actual truth? Because statistics can be used, and statistics, by the way, is just collecting information, analyzing what you got, and making conclusions from it. Okay, so like, let's say I wanted to know what percent of grade 11s and 12s at BH had part-time jobs or summer jobs, just to get an idea, right? How many do you think that might be? What percent do you think that might be? 11s and 12s that either have a part-time job during the year and or a summer job. What would you think? What's that? You think that many? I don't know. There's no right or wrong answer. I'm just wondering.
Is this including like babies stuff or like?
Anything that you get paid for would be considered a job.
Oh, then probably 85.
Really? That high? Okay.
12, like, because you said or summer, you didn't say.
Right. Yeah. Like, yeah, I didn't say, I mean, if you had a part-time job during the year, that would be much lower for students.
Yeah. But including summer, I think it's higher.
But yeah, like, let's say, you know, from September, from September, the beginning of grade 12 to September, the beginning of your first year university, that calendar year.
Oh, that.
You know, like, did you work? Did you do something and get paid for it?
If it's consistent, then like a consistent job, then I would say it's under 50%.
Okay.
But if it's keeping something like babysitting here and there, then I would probably say.
Okay. So, so there's what, about, I don't know, 90 students in grade 11 and 12?
Yeah.
Somewhere around there? Because isn't there around 50 in your grade?
Yeah.
Okay, so maybe it's 90 to 100,
Yeah.
something like that. Okay, and you want to find out, like, did they work from September to September at some point? And would you have, like, would it make sense to talk to every single student?
No.
Oh, that would be very time consuming, wouldn't it? Okay, and it would probably take you a long time to get to every student. So what would you do instead? Okay. And give it to all? Like, let's say you didn't want to make a survey. Let's say you actually wanted to talk to students. You wanted to hear them say it. And you all agree it'd be too much to talk to 100 people. What would you do?
Maybe like choose a number of students.
Okay.
And with a good mix of working people like amount of in both grades.
Yes.
And so the question.
How many? What do you
like,
think?
Based on 100 students?
Yeah.
Maybe like 10 for each grade.
10?
Yeah.
10 for each grade? Sure. 5 for each grade? Okay. We're around 10 to 20.
Yeah.
Would be much more realistic. Yeah. So that in statistics is called taking a sample. Okay. And the best way to make sure that because what you made a good point, you want to make sure that your sample is representative of the population. Like if you decide, let's say we're going to do 15 students and you survey all grade 12s. Well, chances are you're not going to get a result that's accurate. if it's all grade 12s, because usually more grade 12s will work than grade 11s. Okay. So you want to mix, right? And the best way to probably achieve that, and it's what we do in statistics a lot, is take a random sample. Like, let's just say put all students' names in a hat, randomly draw 15. And you should get a decent sample, okay? Or you can, tweak that sample a little bit. You could say, okay, I'm going to put all grade 11s in this hat, all grade 12s in this hat, and I'm going to draw 8 grade 12s because they're a slightly bigger grade, and I'm going to draw 7 grade 11s. That way you're guaranteed to have a representative sample, and it'll be a good mix because it's random. Okay, again, that's statistics, right? So then what you got to do is you got to actually analyze the results and say, okay, this person, yes, this person, no, this person, yes, this person, yes, etc. And you come up with a percentage. And then you draw a conclusion, and you can say, well, based on what I did, I can say that 82%, around 82% of grade 11s and 12s worked at least some type of job where they got paid from September to September. Okay, that's what statistics is about. And so therefore, when people say things like this, those are the kind of questions you want to ask yourself. Like you guys are going to be voting pretty soon. If you're not voting already, if you're already 18 and ready to vote, whenever the next time a vote comes up, you'll see things that say, well, 44% prefer this candidate. And you want to sort of ask yourself, yes, well, how did they actually do that? Right? Because is that actually true? Because statistics, you can bend statistics to give a point of view that you want. You can always tweak numbers. Okay? That's why it's important to have a basic understanding of it so that you can see through that. Okay? Because you could do some type of experiment, you could do some type of survey, and even the way you ask questions, you can influence people, like how you can turn statistics. Okay? Like if I asked you, let's say these two were running for head girl, and I was asking who you would prefer. And I said, so for head girl, would you prefer Sasha, who barely comes to school and is known to probably do drugs and drives around illegally, or would you vote for Reka, who always gives out gifts to people, and she's so kind to people. She buys coffee for people. Who would you vote for? Like, just the way that I phrase that, obviously I can exaggerate it. Okay? But just the way you phrase a question can influence people. Right? Now, like I said, that one was way over the top. Okay? Anyway, so let's.
You missed it. I just want framed for driving illegally and doing.
Yeah, you missed it.
Yeah. I wouldn't be head girl.
Okay. One of the things that we want to know in statistics, or often what we want to know, is what's the norm, or what's the average, or what's the center of a set of information. So like, for example, maybe we want to know the average income of people in Winnipeg, of adults in Winnipeg. Okay. So what does that mean? Well, that means, there's going to be a lot of people that earn little to no money. There's going to be a lot of people that earn a lot of money, but those we would probably consider the extremes. We want to know how much the person in the center of all that, how much would they earn, right? To give us a rough idea. Well, there's three different ways we can measure that. One is called the mean, okay? Which is simply the average. And you guys should be familiar with how to find average. You just add all the numbers up and divide by how many there are. But in statistics, we call it the mean. So if you were asked to find the mean of the following, like let's say these, you wrote 5 tests in a course and these were your marks. And you want to know your average mark. So you would simply add up these 5 numbers. And divide by how many numbers there are, 5. And when you do that, grab this here. You get 74. Now that's not one of the numbers in the set. That's not one of the marks you got. Okay. But that's sort of the middle mark, the center of your marks.
Would that be their term mark?
Yeah, that would be if that's how it was calculated. Like if their term mark was calculated averaging 5 tests, yes. Okay. Another way you could measure the center is something called the median. And that's the middle number in a group. It will actually be one of the numbers. Okay. So in order to find the median, you have to take the list of numbers and you have to put them in order from smallest to largest. So 67, 72, 75, 78, and 78. Which number is in the middle? 75. So that's the median. Notice it's very close to the mean, but slightly different because they are calculated in different ways. In many ways, median is often preferred to mean. Like a lot of times when I calculate how you guys did as a class, I'll calculate your average, your mean, but I'll also calculate your median. Because a lot of the times average or mean is not very accurate. Like, let me give you an example. You don't have to write this down. And we'll talk about this later. So let's say you wrote 5 tests. So you got 0, 100, 100, 100, 100. What's your mean? Add up all the numbers, divide by 5. 80. What's your median?
100.
100. Notice big difference between the two. Which one would be more representative of the center of your data? Probably the median, right? Because this, I mean, this seems to suggest, yeah, you did all right on most of your tests. No, you didn't. You did outstanding on every test except one in which you did awful. Okay? So this isn't really a good measure in this situation. So whenever we have extreme values in a set, median is always a better indicator. Because really, to me, this looks like a 100 student. Okay? This to me does not look like an 80 student. Something happened here, obviously. Okay? I mean, something went wrong. Because how do you go from 0 to 400s in a row? Yeah.
For the median, why wouldn't you have 6 sets? Because then there's no like middle.
And we're going to talk about that. Yeah, good question. The mode is the number that appears most often. So what's the mode of this set? 78. We don't use mode a lot because a lot of times, like what happens if you have a set of all different numbers? What's the mode? Yeah, you could, I mean, there is no mode. If nothing appears more than the others. Okay, so we don't really use it. I mean, it can give us a ballpark figure of the center, but nothing really accurate. Okay, so let's look at this set.
Would there be 2 modes on that one?
Yeah, so if you want to do modes first. Yeah, there are really 2 modes. (96) and 118. Which really doesn't tell us a heck of a lot. That's why we don't use mode very much, because often it's kind of useless depending on the set of data. Okay. For the mean, well, there's 6. Just add up all 6. Oh, forgot a comma. And divide by 6. And that will give us approximately, you have to round it. We rounded it to 1 decimal place. We get 106.2. Okay. Now the median does take a little bit of work because you have to write them in order. You can't just look at this and say, okay, the median is in the middle. They have to be in order. But notice this time, there's 6 numbers.
Would you like?
There's no number in the middle. But there are 2 numbers in the middle.
Would you go a number in between both these numbers?
You would find the average of the 2 in the middle. That's so when there's an even set of numbers, the median is going to be the average of the 2 numbers in the middle. So 102 plus 107 divided by 2, which is going to give us 104.5. Okay, so just remember that for median. If there's an odd set of numbers, there's 1 number in the middle, that's the median. If there's an even set of numbers, there's 2 numbers in the middle, the median is the average of those 2. Okay. And notice the mean and the median are pretty close to each other, which means that there's no, like, the closer these 2 are to each other, that means there's fewer extreme values. And we can see that there's really nothing that is too high or too low in this. Okay. They're all kind of spread out sort of nicely, which is why we get a similar median and median. This example. Here we have 15, grade 12 class with 15 students was polled to determine the number of TV sets they had in their homes. These are the results the students provided. Anybody not have a TV? Just out of curiosity. Are we at the point where we don't have TVs anymore?
No.
Okay. How about, yes, sorry, you're right. I should have asked that.
Oh, no. I don't have that in there. I do, but we only have 1 cable box. like when people want to,
So what do you have instead?
we have Amazon stick.
And that allows you to,
And we have like a Samsung TV.
okay, so really your TV is being used as a projector, right?
Like with the stick. It's like a giant, I don't have it almost, a giant computer, because like the apps are on it.
But you can only, like, what can you get on this Amazon stick? Anything you want?
Well, like there's like Netflix, Prime, like Crave, like
Okay.
all of them. But then on the
What if you want to get just the news? Like if you want to get,
Samsung TV, the news and stuff.
so you do have like,
It's like the news as well. It's like
I see.
So basically. Yeah, Samsung's a smart.
What do you have?
Uh,
What's that?
on my Instagram.
So when you say smart TV, so you don't have like a cable package?
Yeah, it doesn't have. What's it? A
Interesting.
box that says.
I will,
All these ads.
okay, you know what? I need to, because I need to have an extended discussion about this. Appreciate that. How about this set? So after the results are in, one of the students said the median was 1. Where do you think they got 1 from?
Because they just.
Yeah, they just looked at the, like, if there's 15 numbers, the 8th number would be in the middle, because there'd be 7 on either side. So 1, 2, 3, 4, 5, 6, 7, 8, they just looked at the 8th number in this list. Okay, so yes, they didn't order the numbers. And the actual median, well, we'd have to order the numbers. So there's 3 1s. There's
You have everything except for.
3 2s,
Oh, there's just.
3 3s,
Um,
3 4s,
and the last 3 are just 8.
5 7 8, right?
Yeah.
So our median would be 1 2 3 4 5 6 7 8. It would be 3. Yeah. And again, the mode is actually pretty useless in this one. 4?
Oh, wait. 1, 2, 3, 4.
Would be 1 2 3 4, which really is so much. Okay. Okay, the final example. At a small restaurant, the employees are trying to convince their manager they need a raise. So the following diagram displays the salaries for each position.
Is that for a month or yearly?
Per year.
Yeah.
I know, not very much. Okay, so 2 supervisors get 34,000 each. 3 bartenders, 26,000. 2 hosts, 16. 7 cooks, 31. 9 servers, 21. Okay. One of the employees states that the mean salary of all employees is 21,000. Another believes the mean is 26. A third one disagrees and says, no, it's 25,391.30. Which employee is correct? Well, how would we find the mean?
You put it in, no, it's meeting.
Like, could we not, how do we find the total that the 2 supervisors make?
Just times that.
Yeah, 2 times 34. And the 3 bartenders, 3 times 26. And the 2 hosts, 2 times 16,000. And the 7 cooks, 7 times 31,000. Instead of going like 31,000 plus 31,000 plus 30, instead of doing that 7 times, much easier to do this. Plus 9 times 21,000. That will give us the total made per year by all the employees. What would I divide that by?
9 plus 2 plus 2 plus 3 plus 7 plus 10. I'll just start because the biggest number. 10, 14. It's 23.
It's 23. Because you just add up all the employees from each of the sections. And I'll just give you this one. It actually does work out to 25, 391, 30. So the third employee was right. What's that?
I'm just gonna buy, she's pulling numbers in because that's what happened with that one.
Well, you never know because they were all, it's possible it could have worked out to a cleaner number, but yeah, you're right. I mean, especially, I mean, if this is a really weird number, then yes, you're going to get a decimal. Like if you're dividing by 23 or 17, or if you're dividing by 10, you'll get a cleaner number. What do you think the mistakes the other 2 employees made?
I think one of them did the median because 21 would probably be in the middle.
Or would 26 be in the middle?
Well, one of the 2. The median. No, 21 would be in the middle.
What's the most common salary?
21,
Right. So that means this person found the
most times.
Oh, what's it called? The
Low.
most. First employee found the most. And it therefore looks like the second employee. And this, they actually did find this, found the median. Because if you were to find the median, here's how you could do it. Without having to list all 23 numbers. Okay. So the 23rd person, or sorry, if there's 23 people and I list their salaries from smallest to largest, which employee is in the middle of 23?
11,
That's the total number of employees. 11, 12?
13. One of those.
You're on the right track. What you can do is to find the middle number, add 1, divide by 2. So 24 divide 2, 12. So the 12th person. Okay, the 12th person is the middle. When I list their salaries in order. Well, look, so let's find the 12th person. These 2 are the lowest, right?
Yeah.
So that's 2. These guys are next, so that's 11. That's 11 now, right?
Yeah.
That means the 12th must be one of these. So it is in fact the median. Which one do you think that they should use to say they need a raise? Or wouldn't they use the highest one?
Yeah.
So use the median. This is what I mean, that you can sort of bend statistics a little bit to what you want to be an outcome. So use the highest measure, which would be the median. Right? So like I said, we're doing sort of a basic of statistics. And that's sort of generally where we start with stats. Like this has nothing to do with collecting information. This has to do with analyzing information. Because stats is three things. Get the information, certain ways you do that. Analyze the information, which is something that we just did. Draw conclusions, actually, which we did a little bit of, right? Like we analyzed the mean, median, and mode and came up with a conclusion, what should the employees use to maximize their case for a raise.